Hello again. This is another video for my 30SH Pre-Cal Honor students. We're going to go into lesson 2.3, it's lesson 2.4, and this will be like a warm-up. Let's solve for triangle ABC where angle A is 39 degrees, C is 51 centimeters, and B is 42 centimeters. This is one of those problems where we don't give you the triangle, we ask you to make it. So why don't you pause the video and draw the triangle. Don't solve it yet, just draw the triangle. Did you try drawing it, and I'll get back to you in a sec. All right, did you draw the triangle? So we have to put angle A, I'll just put angle A down at this corner, oops, which is around 39 degrees. I don't know if that's 39 degrees or not, but it'll do. And okay, so side C and side B. So it doesn't really matter which one I call which. This is the longer one from what I've drawn, so I'll call that side C, 51 centimeters. And side B is equal to 42 centimeters. And that means that I can close that off, make a triangle out of it. And since that was angle A, this has to be side A. And okay, let's use our sine law. So the sine law says, let's see, that'd be angle B, that'd be angle C. Let's solve for angle A. So, for side A. So for side A over sine of A, that'd be, well, let's see, I could do B over, problem. If I'd said B over the sine of B, I don't know the sine of B. I don't know either of those two things. Okay, well, I can't do that one. So I'll go A over sine of A, and let's do C instead. So that'll be side C over the sine of angle C. Problem again. I don't know the angle across from that side. So I don't know this whole ratio. I don't know that whole ratio. Remember that these ratios have 4 unknowns, and an equation can't be solved when there's 2 different unknowns in it. Right now, I need 3 out of the 4, and neither of these situations do I have 3 out of the 4. Guess what's happened? We've hit a situation where we have side, angle, side. If you remember the activity we did in class together, side, angle, side does define a unique triangle. All triangles with these 3 givens, side, angle, side, will be congruent to each other according to the activity we did the other day. So the problem is not the givens. The problem is sine law doesn't work for side, angle, side. These givens do not solve using sine law. I feel like I'm selling you something on late night TV. There must be a better way. There is. This is where we're going to need something called the cosine law. So I hope you didn't spend too much time drawing that, because we're about to look for something called the cosine law. And it's going to work, we're going to derive it the same way we did the sine law. Do you remember how we derived the sine law 2 whole videos ago? We made ourselves a triangle. Could be any old triangle. Any old triangle will do. I'm trying very hard not to make a right triangle. I think I kind of failed that last time. So there, something like that. Triangle. Any old triangle. That looks equilateral. I didn't mean that either. But anyway, it's a triangle. And in that triangle, we're going to have an angle. We're going to have an angle A. We're going to have, that makes that side A. We're going to have an angle B, which makes that side B. And we're going to have an angle C, which makes this bottom part side C. Now, from there, we are going to do what we did last time. We're going to drop down a height. Right angled, that's height. But this time, we're not going to be messing with sine. This is about cosine. So cosine for, say, angle A would be the adjacent over the hypotenuse. Problem, my hand just froze. Hello, there we go. Problem, well, A to here isn't defined. All the way across is side C. So I'm going to call the distance from here to here x, which means logically the distance from here to here would be all the way across minus that x, so c minus x. See if the logic of that makes sense to you. So I am now going to use 3 different formulas. I'm going to, first of all, like I said, this involves cosine. So I'm going to say that the cosine of angle A is adjacent over hypotenuse x over b. Then I'm going to do Pythagoras to both sides of these triangles here. They're both of these right triangles that I've created by dropping down a height in the bigger triangle. So in this left triangle, x squared plus h squared, leg, equals hypotenuse squared. And in this triangle on the right, leg squared plus leg squared is equal to hypotenuse squared. Now my goal when I'm finished with these 3 equations is to not have an x and not have an h. Because let's face it, I invented x and h. I want something that involves just the a, b's, and c's around the outside, the original triangle, before I started making constructions in it. Well, I can eliminate h right away. Can you see how I'll do that? If I rearrange this formula so that it's h squared equals b squared minus x squared, and I rearrange this formula so it's h squared equals a squared minus c minus x squared, those h's are the same because it's the same height in both triangles. So h squared equals this, h squared equals that. These two things equal each other. Haha, no more h. But I'm left with a couple of x's that I really don't want. How do I get rid of them? Well, you know, the first thing I can do is I can expand that. Expand that using my grade 10 algebra. I'm going to FOIL it. Now careful, I'm minusing this. I'm going to keep it in a bracket. So, excuse me. So when I square c minus x, I get c squared minus 2cx plus x squared, right? Because a negative times a negative is a positive. But I'm minusing all that. So I'm going to distribute, excuse me, I'm going to distribute this negative through the bracket, meaning that it's negative c squared plus 2cx minus x squared. And if you're wondering how I was going to get rid of x, well, I'm almost there. Notice that this side of the equation has a negative x squared. Notice that my finger froze again. There we go. Notice that this side has a negative x squared, and that side has a negative x squared. So if I add x squared to both sides of the equation, oh, bye-bye x squared. Ooh, we're real close. We have b squared equals a squared minus c squared plus 2cx, which is really close to what we want. I just don't want that last x in there. Aha! I haven't touched this formula yet. Cosine of a is x over b, which means x equals b times the cosine of a. I can replace x with b times the cosine of a, and that's what I'm going to do. B squared is equal to a squared minus c squared plus 2 times c times, instead of x, b times the cosine of a. All right, I'm going to rearrange that now because I kind of want a to be the first letter. So I want a all by itself on this side of the equation, and that means I'm going to move these guys to the other side. So b squared's already on this side, and it's positive. C squared on this side becomes positive. And then this becomes, I'm going to rearrange it too. It's going to be minus 2bc cosine of a. And that is the formula that we think of when we think of the cosine law. That's where it comes from. It comes from cosine and Pythagoras. Isn't that a lovely derivation? Oh, the algebra of that just makes my skin tingle. This is a beautiful derivation. So, notice, once again, it was kind of arbitrary which way I did the height. I could have done the height that way. I could have done the height that way. In which case, I could rearrange these letters and say that b squared is equal to a squared plus c squared minus 2ac cosine of b. Pause the video right now and see if you could figure out, without my help, what c squared would equal in the cosine formula, cosine law formula. Okay, try it yourself. Did you try it? Did you get a squared plus b squared minus 2ab cosine of angle c? Notice that these three formulas are really all the same formula. I just remember it as a side squared is equal to the other two sides squared minus 2 times the two sides times the angle between these two sides. And this formula is going to help me out with the problem I had a minute ago. So let's go back to your notes. Notes. Is this the right page? 25. No, I need page. There we go. I want page 24. There we go. Sorry, I'm on the wrong page. There. Lesson 2.4, the cosine law. So there are certain triangles where the sine law does not work. In these cases, we must use the cosine law. And there is, again, the three formulas for the cosine law. And please notice that we're not necessarily always married to the idea that triangles have to be ABC. They could be 3 other letters. They could be STR. So in which case, side T would be T squared is equal to S squared plus R squared minus 2SR times the cosine of angle T. Do you get how I knew that? A side squared is the sum of the other 2 sides squared, kind of like the Pythagoras thing we just used, minus 2 times the other 2 sides times the cosine of the angle between these 2 sides, or the angle across from the side we're looking for. Here's actually the problem we started with. Example 20 is this, this aborted attempt we tried to use sine law on, and it didn't work. So now I am looking for side A, and I can say that A squared equals B squared plus C squared minus 2BC cosine of angle A. Now we plug in numbers. So B squared is this guy, right? And C is this guy. So B squared is 42 squared. C squared will be 51 squared. Minus 2 times 42 times 51 times the cosine of 39 degrees. Does Mr. Kello want me to find that number and all those numbers and write them down? No, he hates stuff like that. He wants you to use your calculator in one button punch. Again, there is no such thing as a calculation so complicated that you ever need to hit the equals button more than once on a scientific calculator. That's the philosophy by which I live my life. So, here we go. 42 squared plus 51 squared minus 2 times 42 times 51. I don't know if you can see that or not. Sorry that it's so dark. Times the cosine of 39 equals 1035.7, 1035.7, and a bunch of change. Now, wait a minute. Gee, that side there looks a little bit short to be 1,000 when that's 42 and that's 51. Oh, yeah. That's not side A. That's side A squared. There is one last step, which would be to square root both sides. So I need to square root my answer, and I get 32 point, I'll just use one decimal place, 32.2. And I just said 2 and I wrote a 3. Centimeters. Yes, centimeters. And there it is. There is our cosine law. Now that it says it wants us to find angles B and C, please notice that it doesn't really matter how I figure that out from here. This is kind of a long and complicated formula. The sine law is a much simpler formula. So now that I know this side, get out of there, cursor. Now that I know this side, I can actually use my sine law and this to find the next one. In fact, I kind of have to. This is one of those cases where I can't just go back to the givens to solve the next thing. I have to use the number that I calculated. So I would, I think, actually just go to the sine law now. So I'm going to go, okay, so let me use a sharper pencil in this one. Is this one sharper? No, this one's dull too. Hang on. Pencil sharpen break. There we go. Let's use this to find, say, angle C. So the sine of angle C over C is equal to, and now I know A across from A, so that'll be the sine of angle A over A, which means the sine of angle C is equal to C times the sine of angle A over A. And this is the smallest I've ever written in my life. The sine of angle C is, so let's see, 51 is side C, times the sine of angle A, which is the sine of the angle I just found, 32.2, and divided by side A, which, oh wait, sorry, that's not the side, that's the side. I want the sine of 39. Thank you. Almost goofed that up. Side A goes down here. That's the thing I just found, 32.2 and change. So sine of angle C is equal to, and you know Mr. Kello, he does not like to repunch decimals. He's going to use his answer button. 51 times the sine of 39 divided by the answer I had earlier equals, and that makes sense that this has to be a decimal less than 1. Otherwise you can't do the inverse sine of it. Inverse sine of my answer And that makes sense. Angle C is 85.8 degrees. Now, I still have one more thing to find. I found angle C. I still have to find angle B. Should I use sine law? Should I use cosine law? How about we just use the 180 trick now that I knew two of the angles? Sounds good to me. Let's use 180 and go home. Angle B is going to be 180 degrees minus, and the first angle I knew was 39. The next angle I just found out was 85.8, and that is equal to, so let's see, 180 minus, open a bracket, 39 plus, the answer I just got, bada boom, 55.2 degrees. There we go. Triangle solved. I now know all the missing parts. I know both of the angles that were missing. I know both of the one side that was missing, and I wasn't able to use sine law to do it because it was side, angle, side. If you are given two sides that are next to each other and the angle between them, you cannot solve it with sine law. You have to use big nasty cosine law. Now, can cosine law be used to find angles? As a matter of fact, yes. Cosine law can be used to find angles when, again, sine law doesn't work. Like, what if I just gave you all three sides? So, go back to the place where we just did our beautiful derivation there, and let's look at this formula. Let's rewrite it. A squared is equal to b squared plus c squared minus 2bc cosine of angle A. What if I wanted cosine of angle A isolated? Well, cosine of angle A is, how do I get all of this to the other side? Well, I'll move the a squared, or I'll move the b squared and the c squared. A squared is already on the other side, but these two have to move over. So that's going to be a squared minus b squared minus c squared all over. And then this part here is multiplying the cosine of A, so I divide both sides by that. If this kind of algebra is kind of beyond you, oh, you're going to hate the rest of physics as you go through the rest of high school. And now, most people don't use the formula this way. Most people don't like this extra negative here. So how about I factor a negative out of the top and then cancel it with the negative on the bottom? So the cosine of angle A is b squared plus c squared minus a squared all over 2bc. And that's the way your book has you remember that formula. So that's what we're going to use here to find angle E. So now let's just rethink this formula with new letters. The cosine of angle E is, notice it's A and then it's the other two sides minus A. So angle E, so that means it'll be the other two sides. So that'll be, what are the other two sides? D squared add F squared minus the side opposite the angle we're looking for. So that's minus E squared all over, and then 2 times these two sides. So 2 times D times F. I guess I didn't actually say which one's which. That's E, that's F, and that's D. And I'm ready to plug in letters. Or plug in numbers, I mean. Sorry, they're already letters. Let's plug in numbers. D is 32, 32 squared. F is 21. E is 41. Notice that you would mess this formula up if you mixed up which one's which, because you have to subtract the one that's across from the angle you're looking for. And then on the bottom, it has to be, of course, the two that are not across from the one you're looking for, the two that are adjacent to the angle you're looking for. So that would be 21 times 32. I just realized I actually didn't mix this up, right? D is the 32 and F is the 21, but you can times 3 things in order. That's not a mistake, really. That's going to work out. So the cosine of angle E. Now, advanced calculator pressing button technique. I'm going to make a mistake on purpose. I'm going to make a mistake on purpose. See if you can catch what it is. Okay, I'm going to move this over so you can actually see this better. There. Can you see that better now? Okay, watch this. Here we go. Ready? 32 squared plus 21 squared minus 41 squared divided by 2 times 21 times 32. Not even close. I dare you to find the inverse cos of whatever 563,000 is or whatever. That is not going to happen. What went wrong? The calculator has to be told that all of this is numerator and all of that is denominator. Sometimes people go, oh, I know I need to put a bracket around that. Watch this. I'm going to do it wrong again. That's right. You get 2 wrongs in a row here. Open a bracket, 32 squared plus 21 squared minus 41 squared, close bracket, divide by 2 times 21 times 32. I once again dare you. Good luck finding the inverse cos of 72,000. What did I do wrong? The calculator doesn't know unless I tell it that all of this is denominator. I actually need to put brackets here and here when I punch buttons. Make sure that makes sense to you. If you need a simpler example, let's just go to a simple example. 8 divided by 2 times 4. We all know that should be 1, don't we? At least, can we all agree that that's 1? 2 times 4 is 8. 8 divided by 8 is 1. Good. So watch. 8 divided by 2 times 4. That's a funny way to say 1. How do I make that a 1? I have to actually say it's 8 divided by, open a bracket, 2 times 4. So I need, there's my 1. I need to do this with brackets. Watch and learn. Open a bracket, 32 squared plus 21 squared minus 41 squared. Close the bracket, divide by. Open the next bracket, 2 times 21 times 32. Close the bracket, hit equals. Don't panic about the fact that the cosine's negative. All that means is we're going to get an obtuse angle. You'll see, it's fine. Negative 0. The important part is that we now have a decimal, because remember, cosine values can't go any lower than -1 and any higher than 1. The unit circle taught us that. But of course, that's not my answer. That's the cosine of my answer. So inverse cosine my answer. And there we go. I told you it'd be an obtuse angle. Angle E is equal to 99.2 degrees. Dun, dun, dun. And as you can see, angle E so looks obtuse in there, doesn't it? Doesn't it look obtuse? Okay, so the diagram's a bit goofy, but you get the idea. 99.2 degrees. We've solved it. Just for fun, anybody got one of these fancy calculators? If you're trying to do a calculation like this on this, one of these bad boys, and you have this button here, feel free to use it. I'm trying to get, there we go. There. Feel free to use that button there. That's your over button. And the over button's really nice because you can actually start a fraction like that and go 32 squared plus 21 squared minus 41 squared, and then just move the cursor down to the bottom if you've never used this feature before, and you don't have to worry about brackets now. It knows that everything you're about to type is denominator. 2 times 21 times 32, and if now you've got like calculator envy, it's like, oh, I wish I had a calculator like that. Well, maybe, you know, put it on your Christmas list. Maybe Santa will bring you a nicer calculator. To be honest, you don't really need a fancy calculator. You just need to know how to use the one that you have. But this is kind of a nice feature. And there you go. Bada boom. You have a, oh, look at that. Instead of a negative 1.1607, it actually gives me the fraction for it. Doesn't matter. Inverse cos my answer, and boom, 99.2 degrees, just like we got on the other one. Whew. That was a big example. All right. Hints for some problems. If no diagram is given, what do I do? Panic. No diagram is given. My God, what do I do with my life? No diagram. No diagrams given. I have no idea what I'm actually supposed to write in here. No diagram is given. Then I don't know. What do you do if no diagram is given? Oh, I guess we draw a diagram to represent the situation before solving the problem. Obviously, you know, I haven't said this in any of the videos for T3 yet, but you know the first thing you should do is just check for a right triangle. Maybe you don't even need sine law and cosine law. Maybe it's just good old SOHCAHTOA, right? If you have a 90-degree angle in it, then just use grade 10 trig, SOHCAHTOA. But if it's not a right triangle, look for a side and, I should say, a side and an opposite angle. If you know a side and an opposite angle, you use sine law. If neither of those possibilities exists, use cosine law. So let's do these two examples together now. And actually, there's 3 more examples. This is kind of a longer lesson, this one. Let's try these 3 examples together. You know what you should do? Why don't you pause the video? Try example 22, try example 23, Try example 24, which gives you a picture you got to draw. And we'll meet back here in a minute and see how you did. All right? Pause the video and see if you can figure out which things to use on your market set. Go. Did you try them? You wouldn't lie to me now, would you? You tried them, right? You've totally tried them? Okay, then let's do them together. Let's see if you're right. In this triangle, do I have a right angle? Well, obviously, if this is 50 and 75, that can't be 90. So it's certainly not SOHCAHTOA. I checked. Not SOHCAHTOA. Do I know an angle across from a side? Well, not yet, but I could in a second. Angle B would be 180 minus 50 plus 75. So angle B is equal to 180 minus 50 plus 75. I can't believe I grabbed a calculator to do that. 55 degrees. Now that is 55, I now know a side across from an angle. That's side B, that's side A, that's side C. To solve for side C, I am using my sine law. C over sine C equals B over sine B. And I like to rearrange the formula first. C is equal to B times the sine of C all over the sine of B. C is equal to, now I'm going to plug in numbers. Side B is 38. Sine of angle C is the sine of, which one's C? Sine of 75. All over the sine of angle B, which is 55. So C is equal to 38 times the sine of 75 divided by the sine of 55. Ba-da-boom! 44.8 centimeters. Done. Side C. How'd example 23 go? I don't know. We seem to be frozen again. There we go. We're back. How did that one go? In the following triangle, solve for angle B. Okay, solve for angle B. How are we going to solve for angle B? I don't know. Okay, here we clearly have a problem. I actually don't have enough givens to do anything, so I'm sorry that I told you to try this. If you tried it, you should have realized that there's not enough givens here. Oh, I see the problem. We have a typo. On my original notes, I'm looking at my old notes from a couple years ago, this number here was 49. Ha ha! Fooled you. Let's put centimeters on them, just to make life easier. There we go. Okay, now pause the video and try it. Guess which one you got to use. Is it sine law? Is it cosine law? Is it SOHCAHTOA? Is it consult a Ouija board? Maybe the spirits can tell you what angle B is. No, it is cosine law. Specifically, the cosine of angle B is, now think back, do you know how your law works? It's the other two sides summed minus the side across from what I'm looking for divided by 2 times the other two sides. That will work. Which one's which? Okay, that guy's A, that guy's B, that guy's C. So the cosine of angle B, I'm looking for that one, is the A side, 49 squared, plus the C side, 39 squared, minus the one that's across from it, 57 squared, all over 2 times 49 times 39. And oh goody, once again we get a chance to practice doing a really good button punch. This is the most exercise I get right here. Is finger aerobics. Open a bracket. 49 squared plus 39 squared minus 57 squared, close brackets, divide by open brackets, 2 times 49 times 39, close brackets, equals. This is usually around the time when somebody goes, don't you have to put those brackets in when you punch buttons? Not really. These guys are just representing a multiply. You don't need to type. That's more brackets than you need. So the cosine of angle B is 0.176 blah, blah, blah. So that means inverse cosine of my answer is 79.9. So angle B is 79.9. That's a 9 degrees. Woohoo! One last big example. Okay, I think there was enough givens for this one. Did you try it? Ooh, you got to draw a picture. A tower is supported by 2 guy wires attached to the top of the tower and fixed to the ground on opposite sides of the tower, 27 meters apart. One wire is 19.3 meters long and meets the ground at an angle of 53 degrees. Okay, I need to draw a picture here. So let's see. I have a tower. There, that's a pretty nice tower, eh? We're going to assume that they put this tower up at a right angle to the ground. It's not the Leaning Tower of Pisa. And we know that it's supported by 2 wires. The 2 wires are 27 meters apart. So it's 27 meters from where the wires meet the ground, here and here. And I know that one side, one wire is 19.3 meters long, and it hits the ground at a 53-degree angle. So there we go. There's our situation. What's the height of the tower? Gee, do I need sine law? Do I need cosine law? Do I need glasses? Can't you see that that's just SOHCAHTOA? Ignore the 27. That's a right triangle. Never lose track of SOHCAHTOA. Sometimes that's the easiest way to do stuff. So height would be opposite. That's hypotenuse. The sine of 53 is opposite over hypotenuse. Height is 19.3 times the sine of 53. Height is 15.4 meters. Sweet. What's the length of the second wire? Now I'm going to kind of ignore that height because that height's kind of just in my way. It's bugging me. 27, 19.3, 53. What do you think? Is it sine law? Is it cosine law? It's cosine law. I'm going to call that angle A, which makes that side A, which makes this side B, which makes this side C. Actually, it wouldn't matter which one's B or C. It doesn't matter. All I need to know is A squared equals B squared plus C squared minus 2BC cosine of angle A. Side angle side means I have to use cosine law. So A squared is equal to 19.3 squared plus 27 squared minus 2 times 19.3 times 27 times the cosine of 53. Punch buttons, my trained monkey. 19.3 squared plus 27 squared minus 2 times 19.3 times 27 times the cosine of 53. Big equals. A squared is 47.4. Nope, misread that. 474.27 blah blah blahs. That's A squared. A would be the square root of that. 21.8 meters. There we go. If you're wondering how I am so quick at punching these buttons, it's because I've been doing this for 30-something years. I'm pretty good at it now. You'll get good at it too. It just takes practice. There's my frozen hand again. This is getting very annoying. There we go. We're back. All right. Finally, what angle does the second wire make with the ground? I would like this angle. Now that I know an angle across from a side, I can use either sine law or cosine law. Really, it wouldn't matter which one. I could do it either way. You know what? This lesson was about cosine law. Let's do cosine law. Let's call this angle B, which means that the cosine of angle B, okay, do you remember how the formula works? It would be the other two, so that'd be A squared plus C squared minus B squared all over 2AC. So the cosine of angle B would equal, and I just found A, so it's that 21.8 squared plus C squared is 27 minus the one across from what I'm looking for, which is the 19.3 minus 19.3, just tidying up my squared there. I got a little sloppy with the way I wrote that. All over 2 times 21.8 times 27. So I don't like to repunch buttons. And the last thing, let me just check. My answer is still 27. Yes, it is still that number, which I don't have to repunch now. So it is. Here, let me move this over so you can see better again. There we go. So it is, open a bracket. The answer that I just had, that 21.8 number, all squared, plus 27 squared, minus, I forgot the squared on that, 19.3 squared. Close the bracket, the top is over, divide, open a bracket for the bottom so that the calculator knows all of that is one calculation. 2 times the answer I had before, yep, you can use the answer button more than once, times 27, close my brackets and hit equals. And if you start having things happen like the screen freezing, thank you very much. If you start having things happen like Oh, it's saying error. Then you've just punched buttons wrong. Don't get frustrated. You just got to try it again. You got to tidy up. You maybe hit plus twice in a row, or you hit times negative or something. Don't panic. It gets better. I know it seems like it's really complicated, but it's actually kind of not. You get used to it pretty quick. So the cosine of angle B is 0.706. Boy, does that look familiar. You know 0.707? If you inverse cosine 0.707, 0.707 is root 2 over 2. This is going to be pretty close to 45 degrees, I bet. Angle B is inverse cos that. Inverse cos my answer. What did I tell you? 45 degrees. Phew! 45 degrees. That was a lot of trig. That was a much longer lesson than I intended. I hope it didn't bore you too much. I hope you did lots. I hope you didn't try that second problem for too long where we didn't give you enough givens. Sorry about that. Check out the homework. This stuff requires practice, guys. Practice, practice, practice. See you later.